Okay, so we're at part 2 of scientific method deconstructed. I'm deconstructing a lab for you. And so now we left off with our materials, 2 round balloons, leather square, which we use to rub against the balloons, and a meter stick. And meter stick is because we want to be able to measure when it says attract the snake from a farther distance than the time being rubbed 10 or 20 times, we have to be able to measure it. Okay, so these should usually be bullet pointed in the materials. The procedure, the experiment, the steps, you may find other teachers use different terms, but this is going to be step by step how you do the experiment. These are typically numbered 1, 2, 3, 4, 5, 6, 7. Step 1, cut a snake out of the tissue paper and lay flat on the table. Step 2, rub balloon with leather 10 times. Hold balloon above snake until it begins to lift off the table. You're not looking to lift the snake. We are looking to attract the snake. So as soon as it begins to lift off the table, you're going to measure the height of the balloon and record it on the data table. You could, if you wanted to, you could see how high you could lift the snake. You could see how long the balloon would hold the snake. But again, this is just we're looking to attract it. And then your steps 5 and 6, you make it very simple. Repeat steps 2 through 4 using 20-time rubs, and every step 6, repeat steps 2 to 4 using 30-timed rubs. So there's no need to rewrite all the steps. You don't want to bore your counterparts in Russia who you're sending this to have them do the lab. They won't like that. Okay, so you are going to put your information into your data table. So here's a data table. We'll come back to our conclusion. Here's your data table. And you are going to do at least 3 trials. You could do 100 trials. You could do 1,000 trials. You have to do at least 3. If you do it once, it's not enough. If you do it twice, it's okay. But if you do it 3, at least you're able to triangulate. You're able to come to some kind of an agreement over that. But you could do more than 3. And most experiments that we'll do this year will be doing more than 3. Then we're going to do 10 rubs, 20 rubs, 30 rubs. It doesn't matter how you set up the data table so long as it's clear and so long as you're able to identify your information, your number of trials, and your independent variable up here. You might want to also put independent variable right here. So you can, when you go to put this in a graph, it makes it easier. And then you're going to want to take these numbers and average them out, because you are not going to put all of these numbers in your graph. For 10 rubs, you want to just average these numbers and see what it comes out to. 20 rubs, same thing. 30 rubs, same thing. Then you're going to come down here and you're going to make a graph. So this is where a lot of times things go wrong. First off, you're going to name the graph as X versus Y. Now, that does not mean you write X versus Y. You don't write X versus Y. Some students throughout the year will write X versus Y. True, it's the X-axis versus the Y-axis, but that is not how you name it up here. You're going to name it by whatever goes on the X-axis versus whatever goes on the Y-axis. So your X-axis is going to be the number of rubs that you have, and your Y-axis is going to be how high or at what point the snake was attracted. So let's take a look down here. So this is going to be a bar graph. Anybody know why it's a bar graph? Because a bar graph is used to compare. When we're using a line graph, we're looking to monitor one point of data over a period of typically of time. So if you're looking to graph your height over the last 15 years, then you would use a line graph. If you're looking to graph the heights of students in the class, boys versus girls, you would use a bar graph because you're comparing. Okay, so we're going to get more into this later on with the specifics of putting the graph together. But put your name up here first. Put your title on here first. Then what you're going to do is on the bottom, you're going to have your number of rubs, which is going to be 10, 20, 30. This is your independent variable, goes on the x-axis. I don't know if I can get this box down any further. Let me see if I can. Oh, I can. Okay. Number of rubs goes down on the bottom. That's your independent variable. What did I write over here? Correctly identified label x and y axes. So you have to label this. See this right here? 10 times, 20 times, 30 times. That's not labeling. Those are units. You're just marking intervals on your graph. Number of rubs. This is your label. So you have to have a label for here and you have to label for here. If you just put these numbers down here, you are just marking your intervals, which is critically important, but it's not labeling. Because if you just put these numbers here and these numbers here, we don't know what they apply to. And your y-axis is going to be snake lift height, whatever you want to call it. If you want to call snake head rising height, snake attraction height, it doesn't matter, as long as it's going to clearly identify what you did in the lab. So here's our x-axis, x versus y. Number of rubs is our x-axis versus y. Snake lift height, x versus y. So far, so good? Okay. Units are always going to be in metric. We do not use U.S. units. The only people who use U.S. units are people in the U.S. The rest of the civilized world uses the metric system. What else do we have to show you here? Okay, so this is it. Now we're going to go over to our conclusion. So we look at this and we see, we're going to analyze our data first. We're going to look at this and we say, oh, 10 rubs, 10 times 10 rubs brought up 10 centimeters. 20 rubs brought it up to about, 15. 30 rubs brought it up to 20. So obviously, the more the rubs, the higher or the further you'd be able to attract your snake from. Let me see what this says, what I wrote here. Sometimes I forget what I write. If you calculate averages, there is no need to plot every trial, only the averages. You have to. You absolutely have to use the averages. You cannot plot all your data on there. Okay, so now we see that the more rubs that we had, the better the attraction. So let's go over to our conclusion. And so now our conclusion says our hypothesis was supported by the data. Or you could have written the data supported the hypothesis. Or if it did not work out, you would say our hypothesis was denied by the data, or you would say the data denied our hypothesis. That has to be your first sentence. The reason for your conclusion is that you are explaining either what you thought was going to happen did happen, or what you thought was going to happen didn't happen. You never, ever, 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 ever say our hypothesis was wrong. No, as long as you're able to test it, it's neither right nor wrong. There's no such thing, unless it's not testable, as a wrong hypothesis. If it's not testable, then obviously it's wrong. But if your hypothesis is testable, no matter how weak you may think it is, it doesn't matter. Okay, so our hypothesis was supported by the data. And then you want to explain what your findings were here. The more we rubbed the balloon with leather, the farther away the balloon was able to attract the snake. That might be able to be worded a little differently. The greater distance between the snake and the balloon when attraction took place. And the fewer times we rubbed the balloon, the closer we had to place it to make the paper snake rise. Okay, so what you would want to put in here and is missing in this conclusion is some numbers. Even though, listen carefully, even though you have your data table here and it looks beautiful, and you have your graph here and it looks gorgeous, you're going to want to put your numbers into the conclusion, because people are not going to look at this. They're not going to look at your data table or your graph. They're not going to look at anything else. All they want to see is your conclusion. Was your hypothesis supported by your data? Was it denied by your data? That's all we need to know. Then we need to know, the more we rub the balloon, you could say 30 times, in parentheses, 30 times, the farther away the balloon was be able to attract the snake. And the fewer times we rubbed, 10 or 20, the balloon, the closer we had to place the snake to be attracted. Okay? So I hope this helps you do your, or understand the scientific method a little more. Since I showed you a lab that we will be covering this year, I don't want you to think, now he showed us the lab, now we know how it ends, now we don't have to do it. No. I will not give you this exact lab. We'll do a snake charmer lab, but something's going to be different about it, and I don't know what it is yet, but I will change something. Or you will change something. You have the option to do that too when we do our labs. Okay, so if anybody has any questions, you can chime in now and speak with your teacher. You should be taking notes. Anytime we have our labs going on, you should be taking notes to make sure that you are going to be able to follow up with this at some time. Okay, so let's take a look, and I think if I can, why am I losing my thing here? Let me see. Oh, there we go. Okay, so if you have any questions, ask, and we will try and answer them as best as possible. Thank you.